exact methods for testing claims about population proportion P. Now, if you identify the sample size n, the number of successes x, and the claim value of the population proportion P, then we can find the p-value by using technology for finding binomial probabilities as follows. So again, the key here is binomial probability, so you'd be using that function if you're using StatCrunch. So for a left-tailed test, you would say that the p-value is equal to the probability of x or fewer successes among n trials. For a right-tailed test, it would be p-value is equal to the probability of x or more successes among n trials. And a two-tailed test would be that the p-value is equal to twice the smaller of the preceding left-tailed and right-tailed values. So let's take a look at an example here. Example 4, using the exact method. In the previous example, we have n equals 19,136 subjects, and 29.2% of them, or 5,588, have sleepwalked. We used a hypothesis to determine whether 29.2% is significantly less than 30%, or to determine whether 5,588 is significantly low. Here, we can use the binomial probability distribution to find the probability of getting 5,588 or fewer sleepwalkers when 19,136 subjects are randomly selected. So let's take a look at StatCrunch. So if I take a look at StatCrunch here, I'm going to go ahead and I'm going to open up Stat, go to Calculators, and then what I want to do is I want to go to the binomial distribution. Okay? So here we know that the sample size of n is 19,136. And the value of p, which was the probability, was less than 30%. So we would put in 0.30. Okay, so if we want to find the following, okay, so here we know that the value of n, which is equal to 19,136, and p is equal to 0.30. Okay, this StatCrunch result allows and shows us that the probability of 5,588 sleepwalkers or fewer is the following, which is the p-value. So let's take a look at that on StatCrunch again here. So here's StatCrunch. We want to find out where it's less than or equal to 5,588. So if I put in 5,588 and then compute, we get the following p-value. We get 0.0080286. Okay, and this is the p-value because it is the probability of getting a result at least as extreme as a result of 5,588 sleepwalkers that was obtained. Now, let's just, for example, take a look at when we would have exact or fewer or greater. So when we want to find the exact value, that means we would put equals. And then if we put equals, we're going to get 0.003428. So therefore, that would give us the exact amount. We just found out that x or fewer would give us that probability, because if we put in less than or equal to, that would be equal to that value or fewer, which is 0.080281, which is what we get there. Now, what would we get for the probability of x or greater? So that means if we then change this to greater than or equal to, then we get the following probability, 0.99231347, and therefore that would give us that value. So, given that the p-value is 0.008026 and the significance level is 0.05, then we would reject the null hypothesis as we did in that previous example. So, we support the alternative hypothesis, and we conclude that there is sufficient evidence to support the claim that fewer than 30% of adults have sleepwalked. So, in proving the exact method, a criticism of the exact method is that it is too conservative in the sense that the actual probability of a type 1 error is always less than or equal to the significance level, and it could be much lower than the significance level. with the exact method, the actual probability of a type 1 error is less than or equal to the significance level, which is the desired probability of a type 1 error. So a simple continuity correction improves the conservative behavior of the exact method with an adjustment to the p-value that is obtained by subtracting from it the value that is 1/2 the binomial probability at the boundary. So here is the simple continuity correction to the exact method. For the left tail test, the p-value is equal to p of x or fewer minus 1/2 times the probability of exactly x. In the right tailed, the p-value would then equal probability of x or more, which is minus 1/2 p times the exact value of x. And then the two-tailed would be the p-value is twice the smaller of the preceding left-tailed and right-tailed values.